So basically, generative pre-trained transformer is, it identifies the context and uses the uh, pre-trained, that is trained knowledge, to understand the context between the words and the intuition behind them. And this kind of technology is used in ChatGPT, GitHub and GitHub Copilot, etc. And this is the core of that is either Copilot or RAG systems, or it could be chatbots. Diffusion models generates images, videos, and audio starting from the pure random noise. The diffusion models is another kind of a generative AI model where it starts from the random noise, a pure noise, something like a human is drawing on the whiteboard. So human has something. If he wants to draw a cat, he knows that there is the cat is an animal and it has two eyes and a nose and 2 ears, something like that. And he takes the whiteboard and starts drawing each and every component of it. And that is at end of the day, like at the end of the art or something, a pure, that is finalized image will pop up for the artist, from the artist. Similarly, this kind of diffusion model starts from the pure random noise and gradually decrease the noise step by step. Something like it starts with painting the eyes. It starts painting the nose and how a cat nose looks like, something like that. All these things, how it knows, how a diffusion model knows that a cat is like that. That is trained with a huge data set of images in the past, whether it is videos or audio, whatever it is. The LLM will be trained on that particular huge set of data, so that it can understand and leverage that particular knowledge to come up with the generation process. So another technique is variation autoencoders. This is also one kind of image generation process where it converts or represents a sample from this. It starts with the compressed latent representation, and then it generates the images. So our scope of today's scope of discussion is the generative pre-trained transformers, GPTs. So as we discussed, the core of the chatbots and this kind of RAG systems and agents is generate GPTs. So the scope of our discussion would be generative pre-trained GPT. So coming to large language model. So large language model can be defined as a deep neural network, or sometimes some people say that it is a huge equation that generates words, a sequence of words based on the input and the knowledge. The input is context, what user is giving to the LLM, and based on the context, based on its own knowledge, it generates the sequence of words. It could be paragraphs, sentences, paragraphs, etc., and learns from the patterns and generates the grammar and based on the context. So a large language model is a deep neural network trained on vast amounts of text data to learn patterns, grammar, and context, enabling it to generate coherent and contextual relevant text outputs. So LLMs, this is with respect to the text. Mostly LLMs are being used for text, but there is an additional capability to it. LLMs can work on, as we discussed, generative AI is working on text, audio, video, images, code, and designs, etc. So LLMs has additional capability of working on all these things. So it can understand the images, understand the videos, and generate the videos also. So there are two things. One is, as we discussed, one of the option is diffusion model and variation autoencoder. and GPT. But GPT has the capability to generate the images also based on the learnings. But these are three different models. But diffusion models cannot work on the text. But whereas GPTs can work on all these kind of models. So here is the analysis of from one of the website, artificial analysis or something, the website name. So it is analyzing the capability of the LLMs based on various aspects. There are a lot of metrics it is being evaluated on. And yeah, one thing is artificial intelligence. Second thing is coding indexed and agentic index. And the website is having a lot of comparisons, but I'm taking for illustrations, I'm taking these three options. That is first artificial analysis and intelligence index. So these are the broad spectrum of LLMs available in the market right now, and there are around 540 or something well-known LLMs are available. According to this analysis, Gemini 3 Pro is well performing with respect to the artificial analysis intelligence. But when it comes to the coding, that could be a Claude. But with respect to the agentic, there is something else, etc. So there are a lot of organizations which are that is creating the LLMs. Something Google is providing Gemini, and Anthropic is providing the Claude. OpenAI is providing the GPT, XI, DeepSeek. A lot of LLMs are available in the market. So LLM can generate the text. So what are all the use cases of the usually we are using? Anyhow, we have been we are well equipped with this ChatGPT, and we have started using the ChatGPT. So it can generate the text. You can ask the question, and it can generate the text, and it can transform the text, and it can translate the text. It can do the reasonings, and yeah, all these aspects. It can do some kind of decision. It can do some kind of analysis through that is when you ask a question through prompt, and when you ask that is there are a lot of prompting techniques, especially one shot, multi-shot, and etc. Yeah, the chain of thoughts, etc. So using a prompt, you can ask an LLM what kind of activity, what kind of analysis, or what kind of output, what kind of analysis it can do, and what kind of output it can generate. So in the prompt, you can mention the context of your discussion. For example, if you know something, some knowledge, if you know something about some either artificial intelligence or financial ETFs. So ETFs are you have some basic mutual funds or something. You know some knowledge about the mutual fund, particular mutual fund, and you want to give that knowledge to that particular LLM and ask questions on that particular mutual fund information. Further questions. So you have a page of information for that part on that particular mutual fund, and you share that with the large language model, and you can ask that questions based on that particular the data you are giving the input. So as we discussed, LLM is a huge equation which is already pre-trained on a set of data. So once the LLM is created and shared across, so once that is shared, that becomes static. The LLM that is a huge file, and you can execute that, and you can query it. Yeah, there are some tools which can be used to expose some APIs on the particular LLM and query that LLM. But in case if you want some answers or some data, or if you want to do some analysis on your own data, LLM is not aware of till now. LLMs are created by the organizations by a set of data that got from that got to that particular organization at that particular set of time. So in case if we want any additional data, it would be a lot of difficult. So coming to the challenges with the standard LLMs, knowledge cutoff, cannot access real-time information. So as we discussed, it cannot access an LLM. An agent or a chatbot can access the real-time information, but a large language model, as a core large language model, cannot access real-time information, which is there available on the internet or whatever, wherever the data source. Hallucinations, generates plausible but factually incorrect info. So you start discussing with that particular LLM, and you have been bombarding that with a lot of questions. At some point of time, or with some set of questions, so it is basic the language you might have used, or the grammar you might have used may not be understood by the LLM. For example, that is Andhra English is different, and Indian English is different, European English is different, and American English is different. But when some kind of inputs to the LLMs, the queries, prompt, may cause hallucinations in LLMs, and that may result in factually incorrect data or inappropriate data for the question. Domain-specific gaps, limited specialized knowledge. Each LLM is trained on a specific set of data, and the data is limited. That is, for example, a particular LLM is trained on healthcare domain, or a particular LLM is generic. There are a lot of LLMs which are generally trained, but there may be missing pieces. So in case if we want to do some research on biology, microbiology, the LLM may not be able to answer a lot of questions because it is not trained on that particular data. No private data access. So in case your organization is having a lot of private data with respect to employees, employee processes, or employee salaries, or a lot of documentation specific to that particular organization in that particular domain. So that private data access will not be available to large language models. Context window limits. So as we just discussed, the input to the LLM is the context. Basically, the number is called context. It is the prompt, and prompt contains the context with the entire the knowledge you want to discuss with the LLM, and then there is a query in the prompt, and there is a output format. What kind of format you will be expecting from that particular LLM. So all these out of that, there is all these things comes into context window of that particular LLM. So at a particular point of time, the size of the request the large language model can receive in a single request is context window. So there is a limitation for each and every LLM. As it is not that you can send a 10 MB file to LLM and ask questions on that particular document. We cannot send the huge amount of data. Each LLM has its own limitations on the context window. Some are 500K, some are 1 MB maximum. I can see the Grok, the 2 MB or something in the recent LLMs. So all these are the different challenges from the standard LLMs when we are using in the enterprises. So how we can resolve them? RAG addresses these by augmenting with real-time, domain-specific, and private data. So one thing is we have LLM, and we can store our own personal data, domain-specific data, or private data on our own storage, and we can give it to the LLM and generate the answers for the queries. Monitor got okay. So coming to RAG is the solution for all these kind of problems. So Retrieval-Augmented Generation combines retrieval-based and generation-based approaches, retrieves relevant documents from external sources, and augments LLM context before generating the responses. So we have our own knowledge bases. A wide set of knowledge bases will be there. We'll be discussing about that. So our own knowledge base will be there, and we will be retrieving the data, relevant data from that particular huge knowledge base for our questions, and send it to a large language model in the context, so that large language model analyzes the content and respond back or do the inference. Sorry, any question? Okay, if it is not question, okay. Yeah, the key advantage is provides grounded, factually accurate responses by retrieving context from authoritative sources and send it to the and analyzing it to the analyzed by the large language model via RAG. Reduces hallucinations through grounded responses. So the responses will be grounded based on the knowledge source, our own, that is enterprise knowledge store, which could be a database or file system or something. Real-time knowledge updates without retraining. So in case if the LLM is supposed to, if we want to train LLM on our own data, it would be a huge task, and the cost of retraining or fine-tuning a particular LLM is very high because of the infrastructure it needs and the CPU cycles it needs. So rather than retraining or fine-tuning the particular LLM, we'll be using RAG. Works with private, proprietary, and domain-specific data. Yes. One more thing is, if the LLM is there and with some third-party organization, and our current organization is having some proprietary data and private data, which may not be shared with that particular. For example, ChatGPT or GPT 5.0 or something, which is being published by GenAI or Gemini by Google. In case, if at all we are using the public LLMs, it may not be relevant to share private data to a third-party organization, and there will be a risk of compromising data. So cost-effective compared to the fine-tuning. Yes, as we discussed, the fine-tuning involves a lot of cost with respect to the infrastructure and time. But yes, the alternative solution is the Retrieval-Augmented Generation, where we will be maintaining what Retrieval-Augmented Generation is. We will be retrieving the documents from our own store, and we will be sending the part of that particular document, relevant part of that particular document, to the LLM in the prompt. That is Retrieval-Augmented Generation. So RAG architecture is something, and this is high-level architecture of RAG. RAG chatbot, and there are a few components, something like we'll be discussing the components later. And RAG chatbot will be doing a semantic search in our own data store, and then prepares the prompt with the context information which is retrieved from the database, attaches that to the prompt along with our question. See, answer the question using the additional context, user question, and retrieved documents. Adds additional context to the prompt and send it to the LLM. LLM will be doing the inference. It will be doing the answer. It will be responding back with the answer. So it is not straightforward. There are so many ways to improve the. It is. Yeah, one thing is we can store it in our own SQL database or file system. The file can be stored in S3 bucket or any any file system or local machines. Or but the challenge with it is the accuracy of the data and accuracy of identifying the best chunk of the data which can be sent to the LLM through the prompt. That identifying that would be a major challenge during the RAG architecture. That is the reason we will be using embedding. There is a technique called embedding. Yeah, I will be discussing about those things. And first of all, here there is a huge knowledge base. It could be images, files, or PDFs, or some kind of drawings, or whatever it is. And we will be doing some kind of encoding. We will be doing that, and we'll be storing it into the database. And during the retrieval phase, this is called knowledge, that is embedding phase, and this is called retrieval phase. During the retrieval phase, the question also will be encoded, and that encoded data will be mapped to the stored data in the database and identifies all the best chunks of data which is stored in that particular relevant context. For example, if this particular store is having all the, for example, movie repository. If this store is having a lot of movie information, and if you want to search for a particular hero, who is the hero of a particular movie, or what is the story of that particular movie, then it will be searching based on your question. It will be searching through the database and identifies all the information which is stored in that particular database about the relevant. That is called semantic. It is not direct search like keyword search, something like Google. You are searching something like word by word, but here it is called semantic search. So, and meaningful search. So it identifies, for example, we have a king. You are searching for a king, and probably the data is having all the details about the prince or an emperor, but all these things are semantically relevant. So that kind of data, if you are looking for a particular hero, all that particular movie or hero details, or that particular movie heroine details, or supporting actor details, all those details will be fetched from the particular database. And as I mentioned, there is a challenge of size of the context. So we will be taking a particular highly mapping data and assigning that to the context in the prompt and sending it to the LLM so that we can retrieve the appropriate information. Yeah, I'll be giving a demo also, but yeah, before that. So RAG core concepts are something like ingestion, pre-processing, embedding model. Ingestion is and pre-processing is something like so identifying the appropriate data and making it into chunks, and like filtering the data and removing the duplicates. All these things will be doing to create appropriate data for storing it into our knowledge store. Embedding model. Embedding model is will be converting into encodings so that we can do a semantic search rather than the keyword search. We'll be doing semantic search. So the embedding model helps us to do a semantic search. Vector database is the store which stores the embeddings in different vector representation. Yeah, we'll be discussing about these things. Retriever is which will be retrieving the data from vector store and assigning that to the prompt engine context. So LLM is large language model, and the prompt engine will be having the prompt, the creation of the prompt with context, query, and the required format, whatever. So output formatter. The output formatter is something like after the inference, like LLM generates the output, there could be a change in the format, the expected format. Again, you will be matching that and like generating into a required format. RAG data flow is indexing and querying. So there are two flows. One thing we discussed about storing the data into vector data stores, and second thing is querying and assigning it to querying and retrieving. So indexing first phase is indexing phase. This will be done in the offline mode. All the documents in our enterprise repository will be loading that into database. So load documents, loading the documents into our own, that is the program context, like for the program, split into chunks. It will be splitted, the documents will be splitted into chunks, smaller chunks, so that can be stored in the vector store. Generate embeddings. The encoding will be generated for that particular chunk, store in vector DB, index for retrieval, so that the retrieval process, that is searching in the vector database, will be easier in case if at all we are doing an appropriate indexing for that particular data stored in the vector database. That is once in activity, but that can be dynamic also. Indexing phase also dynamic also. For example, in case the backend, the data we have may be dynamic, or day-to-day basis we are having a lot of documents coming in, or for example, in an organization, a lot of invoices being raised by the organization, and we want to train the LLM on that particular invoice, all the invoices files, so that in future a manager can ask the LLM, okay, on that particular day, how many invoices got raised, or on that particular day, what is the total amount of the invoice got raised. Kind of querying can be done on that particular invoice data store. So that can be dynamic also. Something very much similar to chatbot. Even ChatGPT trains day-to-day basis what are all the latest news is available. ChatGPT starts storing that into vector stores. Query phase is receive user query, embed the query. So again, the query also embedded and search into, that is encoded into the string, so that the machine can understand, that is vector DB can be searched based on the parameters. Retrieve top documents, build prompt, and milliseconds. Build prompt and respond back to LLM. So this is the indexing flow. So basically, why we do the indexing is so that the machines can understand the text. So humans can read the text, but the way the text is perceived by the perceived by the machines is completely different, and to do the semantic search for that particular text, we will be encoding using a separate embedding LLM. That is also a model which generates the embeddings, from the text or like various multimodal data, and put it into this kind of codes, and will be generated for each piece of data, piece of text we are inputting, and that will be stored in the vector database in different locations. So a vector, the way how a vector represents is across the pan. For example, all the comics stories are going, scientific computing. All the scientific computing information is going into a separate location. High performance computing related story details will be going into a separate location. Speech AI. So the embedding model will be having certain parameters limit, like something like 1,000 or 2,000 or 3,000. So based on those parameters, it will be identifying. Those are not human readable, as LLMs are part of neural networks. We cannot understand that particular embeddings, what is the importance of that, but still machines can understand, and we have to rely on that. So this will be stored in different locations. When again searching for example, happy holiday, I am looking for a holiday information, or wish, what kind of wish he has done. That kind of, when I'm querying for that, again that query will be encoded, and that will be mapped with the existing data store. So document ingestion process, foundation of the RAG transforms raw unstructured data into clean indexed chunks ready for semantic search. So first of all, it will be cleaned and chunks, converted to chunks, so that it can be stored, so that we can send at least a couple of chunks to the LLM. For example, if at all we are using the LLM with the 500 KB context size, the chunk size should be at least 100 or maximum 200, so that we can send at least a couple of chunks to the LLM, so that we can retrieve the data from the LLM and give well enough context to the LLM. So we chunk the files or the images or whatever it is. Data source loading, ingest from PDF, and we will be doing databases. Even though we'll be fetching the data from the database and chunking the data and sending it to the like vector store. API's website, so we can scrap the website. So how the ChatGPT is working is, it has scrapped the latest, that is the news websites, and fetched the data and showed it on the screen when I asked for the latest news. So text extraction, parse and extract meaningful content from various formats, data cleaning, remove the noise, duplicates, etc., so that we don't have the space is equivalent to money. So when we are storing all the unnecessary data into vector, again the performance of the application may be deteriorated. So cleaning the data, text normalization, standardizing the case encodings, remove excessive white spaces, etc. Chunking strategies, split into optimal sizes. As we discussed, the size of the tokens, it depends on what is the chunking strategy we want to use. What is the size of the chunk for that particular RAG? Depends on the model we are planning to use. Metadata preservation, retain source, timestamp, document ID, etc. So that embedding mode converts text into dense vector representations, capturing semantic meaning, enabling similarity comparisons. So as we discussed about the similarity, semantic search. So embedding model is the one which converts the text into embeddings in numeric representations, so that we can store that in the vector store. Semantic encoding transform text into fixed dimensional vectors, so it varies. The size of the vector could be varying. Similarity computation enables cosine similarity. Yeah, there are various computations when we are searching in the vector. There could be the distance between the vectors could be like when we are searching for a particular chunk in the database, we will identify the cosine angle between the chunks, that is the data vectors within the vector database. If it is the angle is very much small, then only we'll identify that as similarity and return it in the response. Something like there are a lot of Cartesian product or something, and there is one more model called distance. So if the vector distance between the vectors is small, the nearest vectors will be returned during the searching process. Contextual representation capture nuance meaning between keyword matching. Yeah, bidirectional understand maintains the context from both directions, like during the retrieval phase and indexing, ingestion phase. Basically, it is called ingestion. Popular modeling models and trade-offs. So OpenAI is having text embedding 3 large. This is one model which can be used for embedding. Something like Hugging Face is giving BGE and BVA AI. So vector database. So there is time vector database, and so there are a lot of vector databases available in the market, and it's a storage. So we have collections, right? One of the collection is vector to store the data in that particular representation. We have a lot of Pinecone, Fias, and Quadrant. A lot of we'll be discussing during the demo phase. So scalability of the vector database is very much important, as we will be storing the huge amount of data in our store, and the response times are very much important to be considered, so that we can retrieve the semantic search, that is we can retrieve the data through semantic search very quickly and send it to the data, so that the entire life cycle response times and latencies would be very little. Retriever, so searches vector database intelligently to find most relevant documents for user queries. So there are sparse retrieval, hybrid retrieval, re-ranking, dense retrieval, etc. All these things are something like, so during the we can store, as we discussed earlier, we can search in even MySQL database, which is relational database, or a graph database, or we can search in a file system or S3 bucket or any store. But the size of the chunk we are retrieving is matters, and the response time matters, and the relevance of that particular chunk matters a lot during the inference phase. Otherwise, it would be. So dense retrieval is query embedding. There are different retrieval strategies from the store. Dense retrieval is that is the process of completely embedding and the documents and retrieving based on the semantic search. Sparse retrieval is based on the keyword search. So we have Elasticsearch. We have something like Google search, how it works in the Google. We will be searching through the keywords, and it will be returning based on the keywords. So hybrid retrieval, there is a possibility in case if there are some we are performing, the delay is fine. For example, if the task can be performed very accurately, the accuracy is important, but the delay is fine in case of some use cases. Then we'll be doing the hybrid retrieval, combining the dense and sparse, normalizing the scores and re-ranking. we'll be discussing those patterns a little later. So hybrid retrieval is the process of combining the, so we'll be doing both dense retrieval from the embeddings, we'll be doing the sparse retrieval from the regular file systems kind of stores, and we'll be combining them and re-ranking them and sending it to the relevance will be re-ranked. Relevance of the chunks will be re-ranked and send it to the prompt. Configuration parameters. So top K values will be retrieved. So when we are this will be similarity threshold, all these things when we are programmatically implementing these things, we'll be identifying that yes, how many chunks needs to be retrieved from the either vector database or any data store. Output formatter. Post-processing component ensuring response are structured, accurate, citable, and user-friendly. So key responsibilities are formatting. We'll be applying the markdowns on the, if in case the response is HTML we are expecting, or we'll be doing the confidence scores. Like in case if we are looking for if 10 chunks are retrieved or and we are thinking that the context may not be accurate, and we want LLM to give the confidence of that particular response during the inference phase. While returning the response, the LLM, if we ask for the confidence score, like how confident you are with this particular answer, then it will be giving the confidence scores, and a lot of validation can be done, and the summarizations can be done, and error handling can be done during the response output phase. So these are the different RAG patterns on high level. Naive RAG is basic flow. Indexing will be done. Yeah. Okay. Sorry. A basic flow of REG, Retrieval-Augmented Generation, where the flow involves indexing, retrieval, and generation. We'll be indexing, generation. It is very basic flow. Whenever we are doing POCs, or when we are doing with sample applications and internal personal utilities kind of, we'll be implementing a native RAG. And advanced RAG is when we are looking for more accurate information. Okay, or a little bit of complexity is fine. Little bit of response time, additional response time is fine, but we want a more accurate and contextually appropriate responses from the LLM. Then we will be using the advanced RAG, where we will be having a additional phase in the post retrieval. In the post retrieval phase, so in the post retrieval phase, we'll after the query from the vector store, we will be doing further re-ranking, further analysis on that particular chunk, that is retrieved chunks against the question, and re-rank the questions, and we will be identifying the relevance of that particular chunks retrieved from the data, and filter them appropriately. In case if we feel that is not enough information, we will be verifying it programmatically. If it is not enough information to for the inference, like to send it to the LLM, then we will be making another call to with a fresh query for the retrieval, and then combine the answers and send it to the generation phase. So by now I hope you understood that indexing is preparing the data, pre-retrieval is preparing the queries, and retrieval is like retrieval is something retrieval is something like searching the data from the database, and post retrieval is once the data is retrieved from the database, we will be doing some kind of analysis on the data and we'll be sending it to the LLM. Generation is happening at the LLM. So there is another set of RAG where RAG pattern, the modular RAG, all that is little further more advanced, and if the response times are minutes are fine. For example, if we want to send an email with entire research automatically send an email with an automated research, or if we want to do a lot of research on a particular technology, if we want to do some in case of biology or aerodynamics or ballistic missiles, if you want to do some analysis on your own document store or knowledge store, the latency is fine, but the accuracy is very much important. The response time is fine, but the information it is generating is much more appropriate to your query. Then we will be using modular RAG, where each phase will be having its own architecture flow. Indexing phase will be having its own architectural flow. Pre-retrieval will be having its own architectural flows, etc. Its own architectural flows. So coming to the indexing, we are chunking optimizations. We will be identifying a very good algorithm for chunking and appropriate sizes for the chunking, and small to big, and then structurally organize. We'll be organizing the data, the entire, if it is stored in as PDFs. It may not be vector store, right? So it could be a PDF stored in some data store. You will be retrieving all the information from different stores. So this is coming under hybrid RAG, where we'll be fetching the details from the database, file systems, vector stores, graphs, or whatever the data stores, and appropriately send it to the context. So even in the context. So pre-retrieval phase, query transformation, how that query can be transformed, and the subquery. For example, if you are asking for analysis on current stocks, around 50 stocks in the NSE. So that will be, so if you ask for analyze and give me the report of top 50 NSE traded stocks with complete analysis on what kind of information, like whether I can invest in that particular stock market or not, in that particular stock or not. In that case, it will be doing subquery. The query will be chunked into further queries. The query a plan will be created. It is called Agentic RAG. Anyhow, we'll be discussing in the next session. So a plan will be created by the agent, so that yes, each and every stock analysis will be done by each query, and then further querying, that is, multiple queries will be done to the data store and retrieve it, and then an retrieval will be done, and then retrieval, post retrieval, those will be re-ranked, regrouped, and compressed, and a lot of operations will be done, and generate the final output, send it to the LLM. But in case of modular RAG, again, all these things will be iteratively executed until the final output we are expecting is received from that particular LLM. So it comes under modular RAG, can be, or can be assumed as a lot of design patterns are there. It can be agentic RAG kind of. Agentic processes can be included as part of this particular modular RAG. Or we can use a particular technique in the modularity, and we can, based on the design or the use case we are planning to use. So the use cases of this particular use cases of this RAG is knowledge management. Internal documents scattered across the systems. Employees struggle to find quick information quickly. For example, as when you join the college, you are not aware of whom to reach out, or what is your salary structure, or what is your the process, leave process. So if you maintain, and there will be a lot of organization. Usually what we do is we reach out to organization website and open the documents each, and identify the process. I read out and identify the processes. But in case if we do RAG, we can query. We can create a chatbot. We can train the chatbot on our, that is, organizational data, and we can query that in just all company documents, wiki, policies, etc. Yeah, the benefits are reduced onboarding, consistent answers, knowledge captures, and 24/7 access. No need to reach out to someone, and etc. Customer support. So repetitive questions, quality queries. In case of this is the RAG is best use case for customer. That is, customer support is best use case for RAG, where for example, the Uber, or in case is Zomato, all, even the pharma websites, all organizations are having their own chatbot in their websites now, so that they are training their the information, and the end users can interact with that particular chatbot and get the information. At the same time, some actions can be performed that can be discussed in the coming up next session, where agents will be involving, and in case if there is any action needs to be performed based on the user input, then agents will be involved. So compliance and legal, where the chartered accountants, legal compliance organizations who reads and tracks and maintains huge amount of documents and knowledge. They, for example, in case if they have to identify and service the customer, a particular customer on. They have to read a lot of books and lot of documentation and support provided by the customer, or the processes given by the governance body. So all these can be set to knowledge stores. Research, yes, research also. In case of research, the best thing is research. I hope you are aware of the Perplexity, one of the site. Sorry. Where we can rely on the research, and it is doing a lot of it is agentic based. One moment, let me. Okay. So when you want to do some analysis on how they are performing financially for the last 5 years. So this query may not be accurate with respect to this query, this our prompt may not be accurate, and the LLM may not be able to understand this kind of query. But the agentic chatbots, something like Perplexity, can understand this query and rewrite this query in a better way, and then send it to the LLM and iteratively create a plan of action, what it has to do, what kind of how it can generate, it can analyze the stocks, and what are all the sites it has to refer. It identifies all of them and analyzes the sites or the documentation. Then or in case if the Perplexity is maintaining some kind of knowledge base or something, that will be referring it to that particular knowledge base also, and finally generate. So analyzing the top 20 and 5 years, it is the complete analysis is being done. So it is referring all these websites, looking up the ticker symbol of Reliance Industries. So the reasoning, what it is doing, the planning it is doing, how it is doing, what kind of steps it is taking. So
Sir, can you please
all
read?
these things are being. Oh, okay, sorry. Compiling a comprehensive list of, yeah, and it is generating the report. Okay, it is taking a lot of time, but yeah, let me go ahead further, and I'll come back to this demo. Yeah. Before moving to question and answers, I just want to demo some one more thing. Yeah, yeah. 6 steps completed, and the steps involved are reviewing the sources, retrieving the details, financial data from these things, and gathering the 5 year stock price history for Reliance Industries, and gathering 5 year annual industries analysis, and all these things. Step by step process it is giving us, and then if the document is being generated, it gives the entire information like market capitalization for the last 5 years, each and every organization, Reliance Industries, information technology sector analysis. It is giving us. So this kind of research is being done by. It is not having either perplexity is not having the knowledge, or the LLM which it is relying is not having the knowledge. It is relying on the public's websites, and in case if it maintains any data also, that is some organizations, some chatbots maintain their own knowledge stores, which will be continuously dynamically populating those knowledge stores on day-to-day basis, scraping the web through web and putting that is those knowledge stores. So this is one example, and I just wanted to demo small program. RAG web scraping demo. Yeah. So I wanted this is a sample Python program which is implemented with this very simple kind of RAG. So usually RAG involves a lot of systems, but this is having in-memory data store, in-memory, and okay. I have used a local host, but local LLM also. But there is one more LLM I am using. Yeah, open router. It is a open router is a proxy and API reseller, and it is I am using XAI Grok 4.1 fast, which is free in that particular open router for the LLM for implementing the RAG. So I am setting up the LLM, and set up open router key. I have already set up, so I don't need to set up that. So scenario one is LLM without RAG. Based on recent economic news, what are the latest trends and developments in India? So as we discussed, LLM cannot find the latest news. But if I ask about what are the latest trends of the development in India in economy, then include the information about market movements, policy changes, and economic indicators. So if I ask the LLM what it responds to, how it responds. Yeah, this is the LLM context without context. I'm not giving any information about the recent trends of the. So it responded back. Fire anyway. What is this? Okay, let me use another router LLM. Or meanwhile, I can. Okay. Gemini Flash. If I use Gemini Flash, what it responds back? Yeah. a specific piece of information. It could not able to even understand what my question is. That's a great start. To give you a helpful answer, I need to tell you to tell me what your question is. It even could not able to understand the question is. Or meanwhile, I'll do that in the local LMR also. And in case, if at all, I am scraping the web, Economic Times website, and let us see how it behaves. And this entire program is scraping the website of the this uh, Economic Times website and getting the details of the understand gold import. These are the top 10 latest trends of the Economic Times. And I'm splitting the article into articles, all these articles into multiple chunks. So total created 10 text chunks from 10 articles. Average chunk size is 407 characters. Example chunk is gold imports drive import India CAT to 1.3% kind of. It is having all the chunks and generate embeddings for each article. So I'm again using the LLM, that is open router embedding LLM, to generate the encodings. So these are the encodings it is creating right now. The data is getting encoded into vectors. This is how it will be represented in the vector store. And scenario 3, LLM with RAG. So I'm embedding the question now. So as we discussed, the while retrieving process, again we embed the question also. The question is getting embedded again, and the question is dimension of 1536, and the question is embedded, and it will be compared. It will be searched in the vector store with the cosine similarity method. So these are the top headlines from the vector store, which are matching, which are at least relevant to that particular query which I have raised. The relevance score is also given to that particular response by the LLM. Create RAG prompt with it is from the vector. It is from the this relevance score is from the vector. If we want, we can ask the LLM also when it is responding the confidence score. That is the confidence score. This is the relevance score by the vector, and we are creating the prompt with the context. The question, this is the prompt message. Recent articles. This is the context we have retrieved from the vector store. We are passing as part of the entire prompt text. So I have typed the prompt text. Here I have, like when I was giving it to the perplexity, I was typing the prompt text. But here I have created the prompt, readily available prompt, and I am concatenating the context and the question to the prompt, so that this entire prompt with the context and question will be sent to the LLM, and LLM will respond back to the question with the appropriate context available in the prompt. This is the simplest form of RAG. Yeah, The trade deficit with 1 minute with RAG. Wait. Sajid Chinoy. It involves. Yeah. Okay. This is the full answer. The response from the based on the recent Economic Times article. Here are the latest trends are and developments in the Indian economy. So FDI policy towards China, government revenue and expenditure. If you look at the link, if you look at the Economic Times website, all this information will be there. And this is the analysis it has done with respect to the later development of India. So this is the query we have raised that with respect to development of India, latest trends in the development of India, these are the trends it has given from the website. So this is one thing. And yeah, now let's move with the questions and question and answers. Any questions? Any questions before taking a break?
Sir. Dear participants, the session will continue after the break, 15 minutes break.
Thank you, Tejaswini.
இதுல எடுத்தேன்
Everyone.
Dear participants, the session is
Tejaswini,
about to start.
can we start?
Okay, sir.
Yes, sir, we can start.
Okay. Yeah. Thank you. Thank you. This 1 minute. Let me share my screen and. Hope you are able to see my screen and.
Yes, sir. Yes, sir.
So yeah, thank you, Tejaswini. And coming to thank you a lot. So coming to the next part of the session today, Agentic AI and MCP protocol. So we just discussed about RAG, which is bypassing one limitation of LLM. There is one more. We can't say it is limitation. That is, we are extending. There is one more additional attribution, like additional feature being added to the LLM by the agentic AI. Something like right now, LLMs can generate the content. It can take the prompt. It can generate the content, but it cannot make any action. It cannot, for example, if we want to send an email, if we want to send an SMS, or if we want to insert a query into that is an entry into database, or if we want to upload a file, any action, or if we want to publish or an image into the Facebook or any social media site, LLM cannot directly do that on its own. So we can have that is we can have agentic AI which overrides that and adds additional capability to the LLM by adding the actions part of the solution, end-to-end solution. So the agenda is introduction to agentic AI, core design patterns, enterprise use cases, model context protocol. MCP is one tool integration protocol. MCP architecture and integration, real world applications, and future roadmap. So, what is agentic AI? So, just now we have seen that, yeah, RAG is retrieving the data and, giving it to the LLM, and it is generating. Perplexity, if you see in the last demo, Perplexity could able to generate a file, a PDF file with entire report. LLM is not having the capability. Either the RAG cannot do that because it is not having a capability to generate the output. It can generate the output in a specific format, but it cannot write into a file. So, what it is, the agentic AI behind the agent behind that particular Perplexity is doing the task. Agentic AI is self-governing system with bounded autonomy that perceives environmental state, reason about objectives, autonomously execute multi-step plans, observe outcomes, and adapt to policies, all within defined guardrails. So it can perceive. It is called perceive, reason, and act. The framework called PRA framework or React framework, reason and act framework. The agentic AI depends on. So the entire the agentic framework leverages LLM and do the reasoning and planning for the input, the query we are using, and it performs a lot of tasks. It can perform a lot of tasks and interact with the tools, external tools, and generate the outcome, the objective, what the user is expecting. So single agent system. So the major concept here is autonomous. The autonomous, the agents are autonomous. The agentic AI is an autonomous in nature, and it can execute, it can create plans and for the ultimate objective the goal user is asking for. So single agent system, agent will be leveraging the tools, LLM, and memory. Goal-oriented planning, autonomous decision making, use of multiple tools and systems, and self-monitoring and adjustment. These are the capabilities of single agent system. So in case of multi-agent system, in case if our solution to be extended for further, it may be one thing is one agent will be retrieving the data from the stock market, and one agent will be analyzing that and reasoning to doing that. One agent will be generating the report, and another agent will be interacting with ICICI Direct. Sorry, any questions? Okay.
No, sir.
So another agent will be interacting with ICICI Direct or HDFC. Like, okay, no problem. So any third-party system, and it may be like inserting that yes, this report we want to store it for the future reference. If we want to upload that to some cloud, okay, and send that report, whatever the report we have generated, to a Gmail for future reference. Yes, we can create multiple for reasoning agent, planning agent, a routing agent in case planning agent and worker agent, multiple worker agents, multiple one research agent, and one scheduling agent in case if we want on a schedule basis, day-to-day basis, this kind of reports needs to be generated and send it to your email. Okay, email agent, and in case if we want to book for a restaurant, these kind of multiple agents can be created, and those can be collaboratively work together to form multi-agent system. So components of the multi-agent system, agentic system. User agent interface layers are like any text or chart, voice, any input, voice input can be given, or audio can be converted by external the two artificial intelligence systems, but yes, some another system, and multimodal systems, sensory systems, APIs, other agents can be interacting with this agent. These are the user interface layer. Memory and knowledge layer. short-term memory, long-term memory, system memory, episodic memory, and procedural memory. So what I feel is these agents are very much equivalent to human nature. We are trying to reach artificial intelligence is trying to reach that is mimic human intelligence. This is uh, very near as of now to the human intelligence. That's what I feel, because the memory and all these things, if you see short term, long term system, all these things, if you see it would look like you are talking to a psychiatrist. Okay, so all these things will be implemented in terms of data stores, databases, or in-memory stores, kind of, and reasoning and decisioning making layer, a reasoning model and task model. So this layer will contain a layer in the sense, yeah, it is a program which will be doing the reasoning and decisions with implementing different algorithms. So yeah, we'll be discussing those things. Automation layer, task execution, process automation, event-driven actions, scheduling. Yeah, all these things will be done at the automation layer, and tools communication layer. So at agent is ultimately has to perform some action. Yes, even if if there is no tool integration, that is called a agent. In case if it is responding back and if it is doing a lot of reasoning and decisioning kind of, and it is responding back with a text message, that is also an agent in robust scenarios. But yes, it has the capability of the tools also, and it can do the web scraping. It can interact with the internet using some tools. It can connect to various databases using the database connectors, external APIs, interface with any APIs, even the Gmail API, Facebook API, etc., and LLM APIs and model integrations. So obviously, LLMs can be integrated with this, and that is also part of tool integration, search and retrieval systems, multi-model inputs, and messaging notifications. Even that, yeah, that will be communicated. So there is, yeah, the difference between agent and agentic and multi-agent systems. So agent is a single AI entity that can perceive input, reason, and act using tools. So that is the PRA framework we are talking about. So the capabilities are users memory and tools, all these things. For example, performance personal finance agent. You say log my coffee expense 500. Agent calls add expense tool and confirms that. It simply confirms that yes, it will be making a call to tool and persist the data that you have spent 500 rupees. That's it. But in case of agent, that is more autonomous and proactive. In case if you create a monthly budget of 2,000 rupees or 20,000 rupees, it will start tracking your agentic application will start tracking whenever you say I have spent 500 rupees for coffee, 200 for parking lot or whatever. It will start tracking and it will notify you based on your prompts you have created. It will start notifying you. Yes, you have reached 2,000 rupees. You have reached 10,000 rupees. Are you in track with your monthly budget? Kind of notifications, autonomously, proactively reaching out to you and guiding you what to do. Multi-agenting system. A team of agents with different roles collaborating via shared context. Each agent specializes in part of the workflow. So in case of multi-agent system, we'll be creating a specialized agents. So in case if we want to develop a software and we want to create a multi-agent software which automatically executes, creates the user stories, creates the design documents, creates the test cases, creates generates the code and test it. So each and every role, whatever the role the end user is performing, that can be automated and by each and every agent. And these agents can collaboratively work together. One agent can share the data, whatever for example, test cases is generated by tester agent, and that will be shared with the developer agent, and it will be shared with, or it will be shared with the reviewer agent, which will be reviewing that is test lead agent, who will be reviewing the user stories, and after finalizing, there will be, in case we cannot completely depend on this kind of agentic systems. In case if we want, we can involve human intervention during all these phases. All these phases are specific phases of the like gates. Delivery gates. During that, we will be implementing, yes, some human will be in at a particular phase. The agent will stop and notify the human using email or something. Yes, the state of the current entire flow pipeline is this one. Do you want to interact and approve that? Do you want to have a review and approve that? Yes, user can interact with that and approve that, so that validate it and take the appropriate action. So yeah, agents can autonomously work, and yeah, multiple agents can collaborate and work for the objective. There are different patterns associated to while implementing the agents. So till now we have discussed about RAG, how LLM works, what is the role of LLM, how RAG works, how it interacts with the database and fetches the data. That is, interacts with the data stores and fetches them and put it into vector stores or the appropriate data stores, so that it can be retrieved by RAG and send it to LLM for the better inference and better output we have been. So here, one step ahead, we are moving towards action. So once it is like we are one step moving forward, and LLM will be doing the reasoning and planning. Based on the planning, it will be performing some actions also. So all these things will be done by agentic applications. So in case of memory, for example, just wanted to give the background of how it works. So in case of memory, we will be using different databases, whether it could be a graph database. We'll be storing it in the R vector database, or time series database, or it could be document database. So fast retrieval, whatever, depending on the memory store we are looking for, we'll be storing that either in memory also. So in memory data stores will be there, caching will be there. All these data stores will be leveraged for implementing the memory. For implementing the tools, yes, there are various APIs can be called. Functions can be called, and interacting with SQL queries can be implemented, or yeah, mostly in case of even the Facebook or all the applications are being integrated with APIs, or whether those are asynchronous APIs or synchronous APIs using the HTTP protocol, or event-driven, something like Kafka queues, queue-based interactions applications will be doing. So yeah, coming to the design patterns. So reflection pattern. During this entire flow, in case if we want more accuracy and these are being measured, the responses of how accurate the responses of these entire either the agents or the agents are the RAGs or LLMs are how accurate will be measured using various metrics. And pattern reflection pattern enables AI systems to examine their own outputs, reasoning process, and decision making to identify errors, inconsistencies, or areas of improvement. These patterns implement self-awareness and self-corrective capabilities, allowing systems to iteratively refine their responses, validate their reasoning, and adopt their approach based on self-assessment. So, this reflection pattern is mainly about validating the final response, intermittent response generated by the LLM, and validate that in case using some techniques. There are some techniques, and in case if there are if it is not directly mapping or not near to what the expected result is, again it will be doing the self criticism and again making a call to LLM with different set of context or different set of query. As we just discussed that when I was demoing the perplexity, I have given a prompt which is very vague. Probably it may not be able to understand for the first. At the first step, it has rewritten the prompt to understand so that the LLM can understand much better. Okay, after that rewritten, that will be sent to the LLM, and LLM will be responding back with a proper plan. Okay, again that will be validated by the plan will be validated by some another LLM. We can use multiple LLMs. So for the reasoning, we'll be using some LLM. For planning, we'll be using different LLM. Or for generation, text generation, we'll be using different LLM. So we'll be using multiple LLMs in the flow and validate that the response what LLM has given, and take the appropriate action by either the response validator. So here, reflection pattern, user is querying the LLM. Initial output is given to again another LLM. Probably it is same LLM or it could be another LLM. And it will be validated by the agent again and again till it gets satisfied and respond back to the query at the end. So self-critic and producer-critic. Self-critic is the agent will be like validating through with that some specific prompts, or LLM is also so against the LLM also will be validating that particular prompt. Sorry, the response, validating the response. There are several patterns, and the final response will be sent back to the. So the reflection pattern is validating the responses for the inconsistencies and errors, and so that further the response can be further improved for the end user. Tool use. So one of the pattern in agent is using the tools. So how the tools can be used? Agent has to interact with a tool. So in how many ways it can interact? It can be making a function call, simply making a function call. But yeah, in case if you understand the programming, you will understand how that happens. One agent will be interacting with another agent or that agent will be interacting with the tool by making some function calls. We can discuss about, that during the demo. So function call and code execution. But the limitation of this function call is each LLM, each function calling, if we are using the technique called function calling, each LLM, for example, if LLM wants to make a call to Gmail, WhatsApp, or ChatGPT, etc., each has to understand what function has to be called from that particular system or component or application. It has to understand that our application has to understand that entire what APIs are being exposed by that. Okay, that limitation is overcome by the model context protocol. Yeah, that will be discussed later. And code execution. So in terms of code execution flow, LLM will be generating a code and agent will be executing that particular code, running in a particular container or running it in a particular environment, virtual environment or custom environment it has created. And yeah, so these are the different tool use techniques. Tool use pattern enables AI systems to extend their capabilities by integrating with the external tools, APIs, databases, and services. These patterns allow AI agents to perform actions beyond text generation, such as making calculations, accessing real-time data, executing the code, manipulating the files, or interacting with external systems. Scope of the task and accomplishing that autonomously. So in this tool use pattern, here query is being sent to the LLM, and LLM, that is LLM directly cannot call. The agent will be making a call to tool with the help of LLM. With the help of LLM, because LLM will be identifying which API has to be called. I'll be showing it in the demo. Tool calling, vector database, tools API, any tool it will be calling, and again it will be it will be coming back to the LLM, the response, and response will be analyzed by the LLM and respond back to the user query. So the objective of this tool use is integrating with the tools specifically. Reasoning pattern. So there are different reasoning patterns represents sophisticated cognitive framework that enables AI systems to process complex information through structured multi-layered approaches. So how the reasoning happen in the agents? So there are different types of algorithms and can be used so in the reasoning agent, or we can implement the reasoning as one complete separate module or agent, or we can implement as part of one agent, one stage in a particular agent pipeline. That also we can do. So during the reasoning phase, reasoning pattern, we can implement different patterns, something like chain of thoughts, tree of thoughts, of thoughts, or react. React is a very basic reasoning technique. It will be something like executing a basic, and it will be querying LLM and understands what to do and immediately makes a call to a tool. It is a very simplest form of reasoning pattern. But in case of chain of thoughts, as we discussed, so as I mentioned, in case if I want 50 top 50 NSE stock report, what it will be doing? It will be splitting that into sub agents. What it has to understand, what steps it has to take. It could be sequential steps. It could be parallel steps. It has to take during the execution phase. But during the reasoning phase, it identifies whether it is chain of thoughts or tree of thought. So a root will be there, and the execution flow will be something like step by step it branches into multiple agents, and multiple agents will be executing multiple agents. That is down what it is, siblings or child nodes, and the responses will be sent back again back to the tree, a top node, and top node will be responding back appropriately. So graph of thought is something which is not sequential. So yeah, one node can be having multiple edges, and it can reach out to any agent, like not any, it is connected to basically multiple agents. It is connected to the like agents will be collaborating in form of graph. So these are all during the reasoning phase. It will be taking different patterns, and during the reasoning, React pattern is the simplest form, and query will be executed given to the LLM, and agent will be executing LLM will be doing the reasoning, and it will be making a call to tool, and tool will be performing an action in the web or something. Like right now it is a environment where it is shown as web, and the result will be again given back to the LLM and respond back. It is a straightforward single flow of reasoning pattern, but there could be very complex flows while performing complex while responding back for executing the complex prompts by the agents. Planning pattern. So sophisticated approaches to breaking down complex objectives into manageable steps, handling dependencies, and so reasoning is done. After that, how the plan? Something. These are all collaborative. Probability. It may planning and reasoning may not be sequential. Sometimes planning will be handing over to the reasoning, and reasoning will be handing over to the planning. Kind of. So all these things will be a pipeline of a flow implementation in the agentic applications. Sophisticated approaches to breaking down complex objectives into manageable steps, handling dependencies, and executing plans while adapting to changing conditions. How the meta reasoning, how I can. The basic planning technique is for example, this flow is query is calling a planner, and planner is generating the tasks. Maybe planner, depending on the reasoning, maybe planner will be depending on the reasoning for identifying appropriate strategy for the planning, and generate the tasks, execute single task as React agent, each and every single task. So generated tasks will be executed by the agent in React pattern we discussed, and it iteratively complete all the tasks generated by the planner by this particular agent, and combine them and send back as a response. So coming to the multi-agent pattern, there is a possibility, yes, as we mentioned, multiple agents will be collaborating with collaborating and communicating between the specialized as specialized agents work together to solve complex problems beyond individual agent capabilities. So this pattern focuses on the protocols, how the agents can communicate during the collaboration phase, communication phase, or coordination phase. So it could be agent to agent protocol. It could be agent communication protocol. These are different protocols. These are the different standards across. So in case one agent to agent protocol states that yes, if one agent wants to communicate with another agent, it has to send the request in this particular format, so that that agent can talk to the second agent. That is, the second agent can understand the pattern how the first agent is communicating with. It defines the schema or the structure, how or the protocol or the transport layer, like a transport layer protocol, whether it is a API or whether it is gRPC or WebSocket protocol. What kind of protocols it can support. So the protocols it defines. The agent to agent protocol will be defined by this particular pattern, and yeah. So PM agent is delegating the work, that is giving some message to the tech lead to implement some program or some task, and task tech lead will be interacting with the DevOps agent. Like he will be in case, for example, if that is, there is an issue in the production, and a PM wants to, project manager wants to resolve that, and that task or story or whatever, it is assigned to tech lead, and tech lead will be identifying, the tech lead agent will be identifying whether that is appropriate to the scope or the scope of his work, or whether some DevOps engineer is supposed to do. If it is the issue is with the program, or if the issue is with the infrastructure or the DevOps pipeline, the deployment pipeline, application deployment pipeline, it will be identifying and it will be delegating appropriately to the DevOps agent with a particular communication message. It depends on what kind of protocol that particular system is using. Sometimes it may be using agent to agent protocols across the agents. Sometimes agent communication protocols. These are different protocols. Each gives different pattern or different schema or different message format to communicate with the other agent. So in case, it will be delegating the work to DevOps, and or it will be delegated to the SDE, and it will be like SDE will be identifying whether it is senior development engineer will be identifying whether it is DevOps engineer or not, and delegating to DevOps engineer. It would be a life cycle. It would be a cycle, like the agents will be interacting with each other on these protocols. Supervisor protocol, supervisor and worker. So in case it is a pattern, like one agent will be working as supervisor, and all the communications will be going through that particular agent. All the like tree, in the form of tree, or that supervisor agent will be guiding what to do by other agents in terms of the prompts. So sometimes what we can implement is, so the agent, tech lead agent, has to do some kind of work, but he needs some guidance. But he cannot make his own decisions, or he cannot evaluate. So PM has identified, in case if it is supervisor and worker pattern, a supervisor pattern identifies that as, and do some analysis on that particular issue, and send in form of prompt, or in form of message. It will be passed on to the tech lead in terms of context sharing will be done to the tech lead agent. So until unless you see how that works, and so these are all different patterns over the agents, how the agents interact, and how collaborate to reach the end objective, or interact with the external tools and do the reasoning. So use cases are something like healthcare, analyze medical reports, assist in diagnostics, monitor patient vitals, and yeah, in real world, mostly any, in my perspective, any kind of role humans are playing in a professional roles like the two white collared roles uh, can be automated through the agents using the agentic API. Sorry, agentic AI and agents. So analyze the medical reports. For example, if I take the analyze medical reports use case, uh, so one patient reaches to the doctor, and asks him to doctor asks him to get the reports. So the patient will go to the diagnostic center and identifies that uh, yeah, he undergoes all that medical tests. The reports are generated. Instead of going back to the doctor, the end user can the patient can do some kind of analysis of that particular medical reports using the agents. In case, for example, he wants a second opinion of the doctor, he can take the assistance of the um, agent. In case it is very simple now, even it is already implemented in most of the case. ChatGPT is doing that. If you scan the medical report using your camera and upload that to the ChatGPT, it is analyzing the entire medical report, or doctor prescriptions also it is analyzing, even though the writing is very difficult to understand. So the characters, OMRs, OCRs, optical character recognizers are able to understand the doctor write prescriptions and do the reasoning and analyze that, and giving the reports, like the analysis of that particular thing. Assist in diagnostics, monitor patient vitals, and automate administrative workflows. In case, coming to the finance, automated trade bots, etc. Coming to the banking sector, onboarding the user. When user, that is, if you are looking for a credit card, if you are looking for a loan, or if you want to create a bank account, or in all these cases, you will be reaching out to a bank support team, and they will be requesting the documentations, appropriate documentations, and you will be submitting those, uploading the documents, and there is an agent who will be validating all these documents, and appropriate eKYC will be done, and all this, the flow, the business flows can be automated with different agents in different sectors. So the one AI agent will be uh, doing all the scanning of that particular the documents and validating the documents, and if the documents are validated, it will be assigning it to another agent to do the eKYC. eKYC will be done by another agent, and once that is done, it will be handed over to the manager for the human in the loop for validation. So the manager will be validating that whether the entire eKYC is done, documents are he is eligible for the loan or he is eligible for the credit card. He will be that kind of underwriting process. Even the underwriting process, underwriter agents are being created, and help the manager, like rating the loan for that particular customer, whether he's eligible for the loan, or based on his credit scores or whatever he's identifying, and giving the entire report to the manager, so that just as a human in the loop, he can validate them and click on submit, so that immediately the loan sanction will be triggered by another agent. So the kind of educational use cases, virtual AI tutors and research assistants, personalized. Just now we have seen that nowadays a lot of students and even the professors are using agents or agentic chatbots, something like Perplexity. There are many chatbots basically to do their research, to submit their projects, or in case of generating the study material. All this kind of study material, or these decks, or the even the demo I have demoed during the RAG, that is also generated by a chatbot called Copilot. The code is generated by the Copilot, and this entire content is generated by the Perplexity and I used even the Microsoft Office, Microsoft Copilot for generating this entire content. Likewise, you can adapt the content, question papers, whatever you give. It is doing many things, and workflows are getting automated. Customer experience, 24/7 AI chatbot and event assistants provide. Customer experience and the supply chain logistic, self-driving cars, self-driving delivery agents. Even the you are looking in the news that the that is bots are delivering the food, bots are delivering the couriers, and even it can help in the inventory management, etc. Enterprise benefits, and obviously the productivity will be reduced by the agents, and it automates time to market. In case if you have any idea, creating and implementing that particular idea is very, even in terms of financial sector, or in even healthcare sector or telecom sector, anything like automating the processes, and time to market is getting reduced. Just when what I am facing is like in IT industry also, we have like something like we are leveraging a lot of agents and agentic tools to automate the entire delivery process, and the delivery life cycle time is getting reduced very abruptly. Something like maybe right now it is 50 to 60%. Earlier, if it was taking 7 days of time for a developer to complete a task, now it is taking around 1 day, 2 days, at max 3 days, including the human in the loop, that is reviews, etc. So the accuracy, reduced errors through consistent AI execution. So there can be human errors in the process flow. So this can be, or it is human psychology, human errors basically. There can be human errors in the pipelines or the flow process flows. That can be reduced or avoided up to some extent in the scalability, handle variable workloads efficiently. Yes. We can scale the agents. For example, if I create a agent that can be implemented for n number of customers or n number of process flows. And in case, if for example, if these agents are implemented for a startup, even if it becomes an enterprise, that is going to be that agents can be scaled up using the cloud environments, or the number of either the horizontal scaling or vertical scaling. Cost efficiency, lower operational costs, and innovation enables new business models and services, rather than focusing on what kind of technologies used, what kind of what could be the development process, or what kind of implementation process, rather than leaders can focus on the innovation and rather than the execution of that particular idea. And I think that is a logical conclusion for the agentic APIs. And coming to the model context protocol, yes, one of the protocol for the tool integration. So tool integration, we just discussed about the tool integration pattern, and in tool integration pattern, one of the protocol used in that is model context protocol. This is the latest protocol which got like introduced or coined during the November 2024, which is automating, which is reducing a lot of effort for integrating with external tools. So as I mentioned during the integration patterns, while discussing the integration patterns, if it is API calling, API function calling, if it is function calling, there are some limitations. Earlier we were doing that, but there are some limitations that each and every LLM is supposed to interact with, has to understand each and every tool APIs. But how API structure, what is the request response structure? So there is complex implementations has to be done at the agent level. But in case of when it comes to MCP, model context protocol, it provides standard interface across the tools, so that tools interact with. Okay, let me go ahead. It provides the standard interface so that for across the tools. So agent is may not be needing to may not be able to understand, or may need not to understand the structure of what ChatGPT, what Gmail APIs are, what how Gmail APIs looks like, what a Facebook APIs looks like, or WhatsApp APIs looks like, or file system APIs looks like. So its model context protocol provides a standard structure to the LLM, and all the complexity of that particular different APIs, API calls or API formats is absorbed by the model context protocol server. So WhatsApp will be okay. Let me moving ahead. And open source protocol for standardized secure bidirectional communication between AI client, Claude ID, AI clients, and distributed context servers. So either the tools, basically here it is context servers, maybe even the not only the context servers, it could be even the whether the resource servers or tools, action performing, task performing tools also. So bidirectional communication, it makes sure, that is, it standardizes and secure the bidirectional communication between the AI clients and distributed context servers. So yeah, using the context exchange and communication, so the context can be exchanged between these agents and the tools. Capability, I will come to that. And communication is through JSON RPC or STDIO. So MCP standardized integration architecture. So MCP host, MCP client. MCP host is the one. For example, you are developing an application. You are developing you are developing a agentic application, or there are some already available tools. Something like just now we have seen the Perplexity. There is Claude IDE. There are some tools, development tools, something like Cursor. Even the IDE is something like Visual Studio Code, or any Claude or Perplexity. And there is one more tool called Comet. Perplexity Comet, basically Perplexity Comet. All these agentic applications assume that this is Perplexity. I just showed that Perplexity is doing some agentic thing. So assume that this is Perplexity, and right now what I have demoed is Perplexity is giving Perplexity is making a generating the report and saving it into the file, so persisting it into a that is the report is being persisted to a file and getting downloaded. And in case if that wants to be integrated with email, that a Perplexity developer has to implement a function call after a certain event from that particular agentic process. It has to make a function call to trigger that particular API. Okay, but here in this case, MCP, this client, that is the agentic application, will be interacting with MCP server, not directly with the actual storage systems or actual services or the APIs. It will be plugged in, it will be interacting with the MCP server, which will be what it is called encapsulating. It will be encapsulating the complexity of the APIs or the third-party integrations, and the standard response structure, request response structure, will be given to the MCP clients, that is agentic applications. Assume that agentic application will be calling MCP server with a single format, and MCP server will always be responding back with a single structure response, specific format, and the entire complexity will be the complexity of this making calls to database. If it is database call is for MySQL, if it is for PostgreSQL, if it is for Oracle, if it is for some graph database, or if it is for like Facebook application, if any file system calls, RPC calls, or remote procedure calls, RPC calls, all these complexity will be handled by the MCP server, so that and responding back. So these MCP servers will be implemented by respective application teams and deployed, so that MCP clients easily integrate with their applications. So host the environment where the model operates, the IDE, agent, runtime, or user interface. So host will be the agentic application. Client is lightweight adapter that sits, that is MCP client. That is the MCP client that sits between the host and server, host and actual server. Sorry, host and MCP server. Translating responses using MCP. So a MCP client is very easy to implement as the structure is same, but the complexity of implementing and implementing the APIs is going into MCP server, which will be taken care by the end application developers. So Postgres will be implementing their own Postgres team, that is organization. Postgres organization will be, our community will be developing their own MCP server and handing over to in the public community portals, and we can either they will be running the MCP servers or we will be running the MCP servers, taking that software, and the MCP server will be exposing a set of tools which can be consumed by the MCP client. Server provides access to structured tools, resources and context, implementing the MCP APIs. Even we can like as application team, like who is developing the agentic application, can implement the MCP server. So before and after, standardized integration architecture. Okay, sorry. Yeah, before and after. Each AI system had custom integrations for the APIs, databases or tools before the MCP was introduced. This made scaling, debugging, and interoperability difficult. The entire complexity of that implementing the APIs is lying into the agentic application. So during the scaling or maintaining that agentic applications is becoming the complex task. But as it is getting encapsulated into MCP server, that is segregated to a separate component and easy to scale either MCP server and the client. Developers had to reinvent the wheel to every new agent or workflow. MCP solved this issue. Providing a universal schema for tools, resources, and prompts, acting like USB-C port for the AI. So so MCP is so in case USB is one protocol or one standard for interconnecting the devices. So USB is having different kinds of USB-C, USB, earlier USB and USB-C. I don't remember the names. So the standard and all the devices which are being manufactured are using that standard and implementing their devices so that they can interconnect the devices. So similarly, this MCP protocol helps us standardize the interconnection of agents and tools. So this is the MCP. MCP and MCP server. Actually, it is one-to-one. Exactly, it is not that one. MCP1, MCP2, MCP3 will be there in the MCP, and each will be interacting with the respective applications. So MCP1 will be interacting with the Notion specific MCP server. GitHub specific MCP server will be interacting with GitHub, kind of. But the standard is same. The way it is interacting, the request response structures will be and like. So MCP components, roles and responsibilities. Each and every components are host. We have discussed like host is the application, agentic application, and the client is we are integrating some additional thing with the host. That is, we are adding something to the host to interact with the MCP client. Okay, and a server is additional component. The host will be interacting with that is host. The client in the host will be interacting with the server, and server will be interacting with the backend. We have already discussed security boundary permissions enforcement and client lifecycle management will be done at the host. Session state of that particular client is coming under the host. Session state, request routing, subscription management, connection establishment will be done at the client, and this is 1:1. So one client will be interacting with one server, one MCP server. So if I want to interact with GitHub, I will be connecting to, that is my MCP server client will be interacting with GitHub MCP server, so that GitHub MCP server will be connecting back to the GitHub. Actual data service providers, server resources exposure, tool definition. So this is the tool definition. So in case if I have to expose the GitHub or Gmail, in case if I want to expose the Gmail, receiving the email, sending the email, scheduling the invite, or kind of APIs will be exposed by the tools. Tool definition. Tools will be exposed by the server, and that client has will be calling the server to fetch what kind of tools you are exposing. To fetch the details, what kind of tools that server is being exposed, it can make a call, and then it can understand that yes, this Gmail server is making Gmail MCP server is exposing two tools. One is receive email, send email. Two tools it is exposing, so that this host logic, in case LLM is wants to send, that agent wants to send any email, it will be interacting with this client and making appropriate. This client will say that yes, okay, I can send the email. For example, at end of the report generation, LLM identified that final stage, a final task is to send the email. Then that LLM identifies, it goes through all the clients configured for that particular configured in that particular host agentic application. Then it iteratively identifies the best tool for that particular use case or scenario, and then leverage that tool and do appropriate actions. Primitives and sharing resources, tools. Yeah. So MCP server is sharing various APIs with respect to tools, prompts, resources. So some MCP servers will be providing the prompts also, so that it can interact with the respective application in case. So MCP protocol is exposing the APIs to retrieve the resources, to retrieve the tools details, and prompts details and notifications. For example, when it comes to notifications, when there is a change in the that tool, MySQL, that is Postgres, is changing its upgrading and changing the queries format or something, then it is then the MCP server has to be modified. Once the MCP server is modified, the agentic application has to be notified that the server is modified. So this kind of notifications will be sent back to the agent application. MCP prompts. So this is the prompt, and this is the standard structure defined by MCP protocol. So name of the prompt, description of the prompt, so that LLM can identify appropriate prompt to execute and retrieve the prompts and execute on the LLM, add the context and add the LLM. So prompts are first-class objects in structured templates with variable, not just raw data text. Okay. This is the standard structure for MCP tools. In case if I want to retrieve the list of tools, tool will be defined in this particular schema. So unique identifier for the tool, human readable description, JSON schema. So that this is based on this context. Sorry, based on this name and descriptions, LLM will identify where this is Gmail sending tool or not. If it is Gmail receiving tool or not, based on this description, it will be identifying. Once that is identified, what is the input schema for that particular tool? What is the input schema for that particular tool will be identified by the LLM. In this particular input schema format, it will be communicating with the MCP server. This is standard tool, but the properties, this is the format, but the properties, for example, email sender MCP will be having a specific set of properties to be sent to MCP server, or receiving will be having set of properties, parameters has to be sent to the. So discovering a client can obtain a list of available tools, invocation tools. I request. Yeah, discovering. One thing is discovering the tools. Has to discovering APIs will be there. Tools allow servers to expose executable functions that can be invoked by the clients. Key aspects of the tool includes discovering, invocation, and the flexibility. Tools can range from simple calculations to complex API interactions. So these can be, one thing is the MCP server is supporting, the protocols are there. MCP capabilities, tools invocation, capability discovery, context sharing and injection, resource access management, streaming and progress updates, session state management, bidirectional messaging, error and exception handling. MCP supports all the security authorizations, etc. Multi-agent coordination and resource listening discovery. MCP transport support the various kinds of protocols. Once, in case if you are running the MCP server in the local development environment, you will be using the STDIO. In case if you are using web applications and remote servers, HTTP or SSE, like HTTPS. WebSocket in case of real-time applications which are asynchronous mode or bidirectional communications are required. Bidirectional communication is required between the in case of video transmissions or audio transmissions. WebSockets will be used, and gRPC is in terms of high latency, that is very low latency protocol, which gives very high performance rates. So complexity is depending on these things, and each protocol type, security, performance, and complexity. So real world applications for the MCP is very much similar to agentic applications, I can say. ID integration for the code analysis and generations, connect to databases. But it is a subset of applications. It is like a component. It is MCP is a component of agentic, not the business systems, analytics, and automation, etc. Challenges are there, and agentic plus MCP unified execution stack. Yes. So in case if we want to combine this agentic plus MCP, agentic can be executed with MCP protocol or MCP pattern or other patterns can be integration patterns can be used. But when we combine them, this is the flow. Agentic control loop, perceive environmental state, reason, react with the reflection. These are the these are the perceive, react, query, MCP tool discovery. This is the phase it gets introduced. This MCP querying will be introduced, execute and learn. So querying the query tool discovery will be is the place where this get in this entire agentic control flow. This is where it get introduced, and MCP will be having the resources, tools, prompts, notifications, and security. MCP abstraction advantage will be agents will be MCP standardizes the tool interface. Agents decoupled from the backend implementations, composable, pluggable system architecture. As we discussed, agents are decoupled from the backend implementation complexities. And that entire complexity is encapsulated into MCP server. Okay. So if I have time, I have some demo for the MCP, but let me see. Not MCP, Agentic with MCP. Agents memory demo. Yeah, I have 3 minutes, but if you have any questions, we can discuss, or I can demo you how this memory looks like. Memory management system, short-term memories, and this is a simple program which executes an agent for persisting the expenses. Like if I say, if I give you a prompt, I want an agent agentic application which is making which is integrated to the SQLite using the MCP protocol. And it can respond back. It can perform your or respond to your prompt something like, I have spent $500 500 rupees in for coffee, and please save it. Or if you likewise, if you start asking, if you start giving the input like I spent on this, it will be persisting into SQLite using the MCP protocol. And finally, if you ask questions, if you can ask that is how much I spent yesterday, how much I spent last month or last week, how much I spent on food. It can understand. Even if you say coffee, even if you say I spent 200 rupees on coffee and persist it, as it is LLM enabled, it can understand. If you say how much I spent on food or beverages, that can be responding back and identifying that and responding back. Okay, it is already 9 o'clock. I'll be sharing sharing this in that Teams chat in case our coordinators, and in case if anyone wants to look at it, can look at it. Okay, yes. We are on time. And any questions? If you have any questions, we can discuss for some time. I am ready. I am okay with that. And
Okay, sir. Thank you very much, sir, for your insightful and enriching session.
Thank you. Thank you very much.
Your explanations, real-time industry examples, and practical knowledge have given all of us a deeper understanding of today's topic. On behalf of Andhra Lailo Institute of Engineering and Technology.